Okay, welcome back. This is Chapter 8. Chapter 8 is all about digital storage. So, as always, turn to page 336 and we'll go over the objectives. Differentiate between storage and memory. Describe the characteristics of an internal hard drive. Identify uses of external hard drives and RAID. Describe the benefits of solid-state drives. Differentiate among various types of memory cards and USB flash drives. Discuss the benefits and use of cloud storage. Describe characteristics of and differentiate among types of optical disks. Explain the types of enterprise storage. Identify uses for mag stripe cards, smart cards, RFID tags, and things of that nature. Okay, so let's begin. So talk about storage medium being that secondary storage. Remember, primary storage is that volatile thing, and secondary storage is stuff that sticks around when the power is out. Okay, so storage medium is the physical material on which the computer keeps its data. Okay, cool. And cloud storage is another storage option where the actual online media is someplace else. So typically media is things that you can touch, except in the cloud scenario where it's not. Okay, so they go on to talk about a kind of a cool definition. It's not bad. Talk about a storage device is the hardware that records and or retrieves items to and from storage media. So, you know, reading and writing to the media. So if the media is like a tape, then the device, the storage device, is the tape drive. Now, so the storage device and then the media. Now, often there isn't removable media. Like a hard drive doesn't have removable media, so the device and the media are all in the same container, right? So there's no separation. Okay, so looking at so all different kinds of things. So we're going to talk about internal hard drives. We're going to talk about external hard drives. We're going to talk about all these things. So one of the things that's kind of weird is we kind of went through this before about what does a megabyte really mean and what does a kilobyte really mean, and how it kind of got complicated because people started making up, the storage manufacturers are the ones who really started cheating first. They wanted to be able to say that they had, you know, a 500 megabyte hard drive, but it was just easier for them to say 500 million because that was smaller than 500 megabytes. So it made it look like it was bigger. So kilobyte is supposed to be 1024, and megabyte is supposed to be 1,048,000 blah 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 blah. That's what it's supposed to be. It's supposed to be this, but of course it doesn't necessarily mean that. And so to remove all ambiguity, there's another little scenario, if you recall, where it's a KIB, an MIB, and a GIB, and a TIB, and that's just to add one more indication that yes, we are talking about precisely the exact number of bytes that we're showing here. Okay, cool. Alright, so that little chart on page 338 is kind of sort of important, but only if you take it in the context of the extra thing with the I. Okay, we kind of sort of mentioned about volatility. This is actually a halfway decent little diagram. So when the machine's turned on, all the stuff in memory and all the stuff on my screen is there, right? And stuff on my hard drive is there. But when I turn the machine off, my screen goes blank, all my memory gets completely wiped out, but the stuff on my disk is still there. So that's a halfway decent way of looking at volatility. The hard drive keeps its stuff where memory and the screen, for example, don't. Okay, let's continue. On page 339, they talk about access time. Now, typically when you're talking access time, you're talking about a hard drive. And so the hard drive, of course, is this little guy that looks like this. You know, this is one with the cover off of it. You know, without the cover off of it, you know, they kind of look like one of these guys. I mean, it's got a printed circuit board on one side, but it's got, you know, a metal case on the outside. So now that we're talking about the right thing, access time is how long it takes for the storage media to, if it's at one point in the storage media, how long does it take for the device to move to the next spot? And if this was a tape drive where you had that sequential storage, the access time might be, minutes to get from one point to another. On hard drives, the time is relatively small, and so we're talking milliseconds time for the machine to go. It's reading over here, and then all of a sudden, boom, it has to read some other section. So to make the machine more responsive, you want the least amount of access time. The amount of time it takes for a storage device to locate an item in its medium. Yeah, so you really want things that have low access time, and we're going to be talking about solid state disks. But solid state disks have the smallest amount of access time of all the storage media that exists. And so it's actually pretty doggone good for certain types of features, which we will discuss. Okay. So continuing towards the bottom, page 339, they talk about what a hard drive is. Yeah, it looks like this. Here's their definition. It talks about a hard disk contains one or more inflexible circular platters that use magnetic particles to store data, instructions, and information. Okay, so in essence, the disks are these little platters, and they're these typically metal plates, and they've been coated with a magnetic media, and they have a little arm that sticks out here, and this arm can move. And so you could have a stack of these things. You could have a hard drive that only has one spinning disk. That works. But you can also have them stacked up. So in this particular case, there's 3 spinning disks. And so I have 3 disks, and I have a read head on top, a read head on this one, a read head there, and a read head there, a read head there, a read head there. So I have 3 disks, but I've got 5 read heads. Okay, make sense? Actually 6 read heads, isn't it? 1, 2, 3, 4, 5, 6. Yeah. I got 6 read heads on 3 platters. And all the read heads kind of move together, so that's a little hinge right here, a little pivot point right there. And so there's a little motor that kind of makes it just arc back and forth like a record player arm. It just moves back and forth across the disc. Okay, so that's essentially how these things work. Okay, there's some details in the book about perpendicular storage and all the rest of that stuff, but that's kind of into the weeds. So let's just continue. They talk about formatting the hard drives. Now, in the old days, you would buy a hard drive, and it may be you wanted to buy it, and it was just raw, so to speak, and you wanted to format it. So you would stick it in your machine, and you'd run this little, format C:, or whatever the drive letter was, and it'll go out and lay down all of the tracks. We haven't even talked about what a track is yet, but just bear with me for a second. We're going to get there. Nowadays, that is not what happens. When you buy a hard drive today, the tracks were laid out at the factory, and you don't have the software you need to be able to do that. So it may say, would you like to format this hard drive? Like when you're in Windows, right? And you go in there and you say, hey, I'd like to format this guy. It says it's doing a format, but in reality it's not. What it's really doing is just doing a really quick read test to verify that everything's okay, because your machine no longer has the ability to lay down tracks. And the reason is, it used to be pretty simple to lay down tracks, because I had tracks started right here really close to the hub, and let's say I'm making these numbers up. Let's say it had 16 spots that it could use, and on the outer edge it had 16 spots that it could use. Well, these are moving faster, aren't they? Right? Than the ones in here, just from mechanics, right? And so newer hard drives don't have the same number of spots as it moves out towards the circumference. When it moves out towards the edge, it actually has more numbers of spots. So you might start off with 16 spots here and end up with 30 spots there. And you just don't have the software installed on your machine that allow you to do a true, honest-to-God, low-level format. So low-level formats are only done in the factory now. There's no way you can do that on your own. Okay, so let's continue. On page 341, at the top, they talk about a dock. So let's say, for example, that I've got a spare hard drive sitting around, and I want to be able to use it in my machines. Well, here is a little docking station. And so what you do is you take your hard drive, and you just plug it into this little dock. It just slips in. That's like that. The USB port plugs into your computer, and presto changeo. Now, if I have an old hard drive sitting around someplace, then I can just buy one of these little guys. They're dirt cheap, like 40 bucks, and hook it up, and now I can get files off my hard drive with no trouble at all. It works great for laptops where you have like no chance at all of being able to crack open the case and run a cable or anything like that. So little docking stations are actually pretty doggone cool, and of course dirt cheap. Okay, so they talk about some terms, and the terms are we just talked about tracks and sectors and things of that nature. So a track is one revolution where the head goes, and so the more tracks you have, the more data you can put. So if you had a physically bigger disk that was spinning, you could have more tracks. Or if you just squashed them together a little closer and closer together, you could have more tracks. And the tracks have sectors. And so the inside, again, in the old days, you started out here, you had the same number of sectors every single time. If you had 16 sectors on track 1, you're also going to have 16 sectors on track 4000. I mean, it's not going to change. That's not the case now. In fact, since the hard drives were designed for that, there is some logic inside the hard drive that fakes it all out, that makes it look like all these things are symmetrical, that there are actually the same number of sectors per track. It's all smoke and mirrors, because behind the scenes that is not what's happening. But in order for the disks to be, you know, backwards compatible and to be able to plug into practically any device and work, they basically just had to say, look, we got the real world, how many sectors per track, and then we got the logical number of sectors per track, and we'll take care of making that transition for you so you don't have to worry about it. Okay, platters, we talked about each one of these guys is a platter. There's a thing called a cylinder, okay, and a cylinder is that same track, but including all the surfaces, all 6 surfaces. So I would go track 1 on this platter, go down 1, track 1, 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 come back. So I do track number 2. So a cylinder is all 6 of those surfaces on track 1. The form factor. This is a standard called a 5.25 inch disc, a standard size. There's some other ones, the littler ones that are designed mostly for laptops and things of that nature. So when you're buying hard drives, there aren't that many choices, but basically you just have to know, you know, what size that you're going for. You know, most desktop computers are gonna use the old style guys, the bigger ones. The read-write head, we talked about that. This is a little doodad right here. And how many revolutions per minute? So the faster transfer rate, we talked about access time. To make a hard drive access time go faster, you need a really cool motor here, right? You want a super duper motor that can go doop, 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 really, really fast. If you had a really wimpy motor, it would just kind of go nuh, 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 nuh. Well, then your access time would be pretty poor. So you want that thing to be, lightning fast, back and forth for the access time to be good. Well, that takes an awful lot of power to do that. And to make the transfer fast, the platters have to be spinning really high. In a typical enterprise style storage device, it's not unheard of to have hard drives at 15,000 RPMs, and that's how fast those guys are spinning. For typical, stuff that you buy in the store, it's like 7,000 RPM. And some of them, this is what's called a green drive, a power-friendly drive, and it actually has a variable speed. It starts off spinning at one particular speed, but if you're not using it much, it'll kind of slow down, and when the head goes out towards the outside edge, it slows down a little bit more. Kind of cool. Anyway, so the number of revolutions per minute, the RPM rating on a drive, is one of the factors when considering the performance of a drive. Okay, this is probably a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.